Okay, so related rates. Basically, related rates are nothing more than applications of implicit differentiation. Okay, so, and most of them are going to be some type of word problem. So the first and foremost thing you have to do is start by reading all of the problem. So a cube of ice is melting. The side S of the cube is decreasing at a constant rate of 2 inches per minute. How fast is the volume V decreasing when the side is 3 inches? Okay, so the first thing you need to do is you need to figure out what they've given you, what type of information. So it's telling me that the side of the cube is decreasing at a rate. So they're telling me that one of the things that I know is that the rate of change of my side length per unit of time is negative 2 inches per minute. That's what they're telling me. The fact that they're saying the side length is decreasing, we know it's negative, at a rate of inches per minute. So that's how my side is changing over time. Okay? What are we looking for? Well, that's what they're telling us. That we are looking for how the volume is changing over time. So dV over dt, that's what we are looking for. They also tell me that we're looking for that at a specific moment when the side length is 3. So they're telling us S is 3. Okay? So the next thing we have to figure out is a actual equation that relates everything. Well, we're dealing with the volume of a cube. So you should know the volume of a cube is S cubed. Okay? So we're dealing with rates of change. So we're dealing with it with respect to time. So we're going to take the derivative with respect to time. When we take the derivative of volume with respect to time, we get dV over dt. When we take the derivative of s cubed with respect to time, we get 3s squared times ds over dt. And that's the implicit part. Since my variables don't agree, my variables don't match, I'm left with the derivative of side with respect to time. Okay, so this is what I mean by basically implicit applications of implicit. So since we're trying to find specifically the how volume is changing over time, that's this part. We're trying to find this. Well, do we know what ds over dt is? Yep, negative 2. Do we know what s is? Yep, that's 3. So we just plug it in. So we get 3 times 3 squared times negative 2, which is 3 times 9 times negative 2, which is negative 54. And since we're dealing with volume, it's inches cubed. That's it. Okay, the hardest part about this is going to be taking the derivative implicitly. Okay, after that, it's basically an algebra 1 problem.